Stargazers and space experts are stunned by the looming vanishing of the North Star, Polaris. This occasion is expected to be the following enormous thing in the universe of astronomy. Yes, you heard that right. Polaris is going to be focused on our starscape for good, and this approaching divine disaster conveys significant suggestions for our ground-based telescopes, which use it as a kind of perspective point for their adjustment and exactness. Brian Cox cautions that Polaris's blast is fast approaching and will change the night sky perpetually. We should dive further into the account of the North Star and why its end matters so much. For centuries, Polaris has been a divine aid for both stargazers and guides. However, all of this might change in a matter of many years, if not sooner. A new research work introduced to the regarded imperial galactic culture in September 2023 has essentially fixed the destiny of this guiding light. Polaris is on the verge of a disastrous event, a blast that could bring about its vanishing from the night sky, forever modifying our enormous compass. Yet, before we dive into the possible results of this disclosure, how about we investigate the star in question, otherwise known as the North Star or Pole Star? Polaris holds a unique position in our night sky because of its closeness to the heavenly North Pole. It sits straight over the Earth's North Pole, giving the illusion of being practically fixed in the northern sky, situated in the Ursa Minor constellation, which is additionally known as the Little Dipper or the Little Bear. Polaris sparkles as a decently brilliant yellow-white, very giant star. It outshines the sun in brightness, emitting significantly more light across the infinite material. Besides its sheer size, it overshadows our sun, boasting a radius estimated to be multiple times bigger. Notwithstanding its apparent peculiarity, Polaris is part of a complex triple star system. Two of these, Polaris AA and Polaris AB, appear as a single star to the unaided eye, while a third companion called Polaris B orbits this double pair. The complex gravitational interactions among these stars impact their orbits and luminosity. These intricate elements can cause sporadic variations in the star's brightness and pulsation patterns, yet the specific mechanisms behind these interactions remain a significant mystery. On top of all of this, the ever-increasing distance of Polaris from our planet adds a fascinating worldly twist to our understanding. Since it is 323 light-years away from us, the light we see from Polaris today set out on its interstellar journey over 300 years ago. If we were to see Polaris explode right now, it would have actually done so all those years ago. The Earth, quite a while back, was very different. In the mid-18th century, humanity was navigating through a period marked by significant historical events and social movements. It was a period marked by the end of the Renaissance, the beginning of the Enlightenment, and the start of the modern era. In some parts of the world, scientific advancements were gaining momentum with figures like Isaac Newton forever changing the scientific landscape. Concerning daily life, society was still largely agrarian, with farming being the primary occupation. Urbanization was gradually increasing, leading to the growth of cities and the expansion of trade and commerce. Socially, art, music, and craftsmanship were gaining prominence. So, if Polaris were to explode tomorrow, it would have done so during a time of change, exploration, and transformation, paving the way for developments that would shape the centuries to come, much like how this event would change things for our future. Throughout the centuries, the North Star has woven its significance through the tapestry of civilizations across the ages. This stellar guide served as a guiding light for ancient sailors and explorers, illuminating their paths across vast seas and unknown landscapes. Polaris has been a reliable beacon, guiding travelers in the Northern Hemisphere and enabling them to chart their courses with confidence. Polaris has embodied a cultural and navigational foundation for millennia and has shaped the story of ancient explorers, navigators, and scholars alike. So how do we know that the star is approaching its end? Designated a Cepheid variable star, Polaris has distinctive properties and stellar measurements. Its anticipated brightness fluctuations have been instrumental in unraveling secrets about variable stars and calibrating galactic instruments. These rhythmic pulsations have generally followed a solid pattern, helping astronomers predict its behavior with ease. However, in the aforementioned research paper, scientists revealed a deviation from this normal pulsation cycle that has alarmed the cosmic community. Polaris has adopted an erratic, unusual cadence of dimming and illuminating. This anomaly has prompted extensive investigation, with astronomers striving to understand this celestial inconsistency. This departure from its norm has raised concerns among scientists, indicating that Polaris may indeed be approaching the dusk of its existence. Polar's pulsation period has recently begun to extend. The star was previously stable in its cyclic brightness shifts. However, now astronomers have noticed a gradual extension of the pulsation length, with an annual increase of 4.5 seconds. While seemingly minute, this change holds significant implications, indicating a substantial departure from its established behavior. There have been several hypotheses regarding this shift. One possibility is related to gravitational interactions within the polar star system. These interactions could be altering the star's environmental conditions, directly affecting its pulsation patterns, or more specifically, how we perceive them. However, dissenting voices in mainstream science suggest a much more disturbing possibility. The star is dying. Whether as a result of gravitational interactions or as a harbinger of a looming celestial explosion, the anomalies in Polar's behavior have ushered in a new era of cosmology, one way or another, set to change everything we thought we knew about triple star systems like Polaris. Discussing how discoveries change our perspective, in 2006 we got a close look at Polaris courtesy of the Hubble Space Telescope. Astronomers also revealed the elusive companion star, settled so closely to Polaris that it had been difficult to observe it previously. This was the very first image of our celestial neighbor, capturing today's bright light. We know that the companion Polaris b orbits the central pair at a distance of around 2 billion miles. Despite having inferred its presence from light examinations of the triple star system nearly a decade ago, its faintness compared to Polaris hindered direct observation until the Hubble Space Telescope made it possible. This all began with the launch of the Hubble Space Telescope, HST, in 1990. Its deployment opened a window to the universe, providing unmatched clarity and rethinking our understanding of astronomy. The HST captured celestial wonders that reshaped our fundamental comprehension of space. Among its famous achievements stands the iconic image known as the Pillars of Creation in the Eagle Nebula, which houses massive columns of gas and dust where stars are born. Another milestone came with the discovery of the Hubble Deep Field, an apparently empty patch of space that, upon closer examination, was teeming with thousands of galaxies. This single image expanded our perception of the universe's sheer vastness and complexity. The HST also studied exoplanet atmospheres and revealed tantalizing hints about their composition. The presence of elements like water and organic molecules in these distant realms hinted at the intriguing potential for habitability beyond our solar system. Building upon the legacy of Hubble, its successor, the James Webb Space Telescope, JWST, was launched to push the boundaries of technological advancement further. With lessons learned from Hubble's endeavors, the JWST is poised to delve deeper into the mysteries of the universe, continuing the tradition of exploration and discovery started by its esteemed predecessor. One of the JWST's standout features is its unparalleled ability to capture cosmic vistas with striking clarity, dispelling the dark shadows that once obscured our celestial observations. The telescope operates primarily within the infrared range, penetrating through cosmic dust and revealing celestial treasures previously hidden from human sight. At its core lies a massive 6.5-meter primary mirror, composed of 18 hexagonal segments, surpassing Hubble's mirror in sheer size and precision. Situated approximately 1.5 million kilometers away from Earth at the second Lagrange point, L2, the JWST effortlessly trails Earth's orbit around the Sun. From this vantage point, it provides us with an unobstructed and vigilant view into the cosmic web. Yet, the journey into the universe isn't merely a journey across light years. It's a journey through time itself. The JWST utilizes cutting-edge infrared instruments capable of looking back billions of years into the past, capturing the ancient light emitted by celestial objects as the universe expands. This light undergoes a transformation known as redshift, shifting from its original visible range to the infrared spectrum, or longer. The JWST is perfectly suited for detecting and unraveling these infrared signals from distant cosmic entities. It is now set to alter our understanding of Polaris as well, unveiling clearer than ever images of the triple star. This innovative telescope heralds a new era of cosmic exploration, ready not only to reveal the distant reaches of the universe, but also to unravel the mysteries of our cosmic past. With its remarkable capabilities and unique vantage point in space, the James Webb Space Telescope stands as a beacon of human ingenuity, uncovering the secrets hidden within the celestial domain. Thus far, we know for certain that there are intriguing parallels between Polaris and Betelgeuse. Both of these giants are expected to approach their ends. Betelgeuse is a prominent star in the Orion constellation and has exhibited puzzling anomalies in its brightness, similar to what we observe in Polaris. This similarity has prompted scientists to consider the possibility of an impending explosion, echoing concerns raised about Betelgeuse's inevitable fate. The uncanny parallels between the changes in brightness and patterns displayed by the two stars have certainly attracted attention from researchers worldwide. At the end of their lives, stars often transition into different phases, culminating in events such as supernova explosions or the formation of neutron stars or black holes. Betelgeuse and Polaris are both experiencing processes leading to their eventual demise, setting the stage for cosmic transformations that will shape their stellar legacies. Polaris's fate, closely monitored by astronomers, underscores the profound significance of these celestial phenomena, urging us to deepen our understanding of the universe's dynamic nature. In this cosmic tale, we're part of a much larger narrative, one where stars, like Polaris and Betelgeuse, are symbols of cosmic evolution, illuminating the universe's vast and ever-changing expanse.